Hi, and welcome back to the Cuzzy Sound channel, and part 3 in the series all about my Project XII Modular Synth. In this video we'll be looking at the 4046 VCO. In fact, we'll be looking at 3 of them, there's 3 in there. Now, unlike the 3340 VCO we looked at in the last video, this one does not follow the 1 volt per octave standard. However, I hope to show you by the end of this video that is not a problem if you want to use these things in composing and playing music. I don't think that it should be a holdback. In fact, I find that having to work with something that doesn't just slavely follow whatever you play on the keyboard actually gives more of an involvement in the creative process. But more about that later. We'll have a look at the panels in the synth. We'll have a look at the circuit, but it's exactly the same circuit as the one I put in my little boxes. There'll be a link somewhere up here that'll take to the video all about that one, and the diagrams and the board layout are in that video, but I'll probably put them at the end of this video as well, just so it's all in one place. The main difference is that in the synth here, two of the oscillators are on one panel, and they can be either run independently, or I've got switches on there, which means they will share the CV input and they also share the outputs. So you could run them as a dual oscillator. That's great for kind of detuning one against the other and setting up kind of like a power chord kind of effect on. But we'll hear more about that later, because I'll do a quick demo as well on this video. So let's come over to the bench and have a look at what the 4046 VCO looks like. This is the single oscillator panel. Very, very simple layout. Pitch control on the knob at the top there. Audio out. CV in. I haven't labelled this one, but this is a modulation in, which creates some crazy effects. If you do go and have a look at the little boxes video, I'll demonstrate that in there. So you get kind of like a almost sound effect type output from when you modulate that. So nothing complicated, very, very simple oscillator. What does the circuit look like? Well, that's the circuit. You can see we have 4046 chip, which is the oscillator itself, and then there's an op-amp that basically provides a conditioned input and a buffered output. So that's it really. Very, very simple. But yeah, if we move up and have a look at the dual oscillator panel actually in the synth, you can see how that one is arranged. Basically on the inside it's just 2 of these side by side. So the circuits are exactly the same, it's just the way I've arranged them. So let's move a little closer to the synth and have a look at that panel in situ. These are the panels mounted in the synth. One thing I didn't mention earlier was that in the little boxes version they're running off a 9 volt battery. In the synth here they're running off the plus 12 volt rail of the power supply. It doesn't need the minus 12 volt rail, just ground and plus 12 volt. I haven't made any alterations to the circuit, not changed any component values. I'm just simply running it off 12 volts, and it works fine. No need to make any alterations. So let's have a look at what we've looked at. The single oscillator. Look at the dual oscillator panel. So we've got pitch controls again. Basically it's the same as the single one over there. Each one has its CV input. I've got some LEDs indicating the CV input, although the choice of the green one was not great, it's not very bright. I think it needs too much voltage. Then this first switch, in the up position, these are completely independent. In the down position, it actually just simply joins that input to that input. It's not buffered, they just simply join together, so you can get a little bit of interference, but it does mean that I can put a CV signal into either of those sockets and it will affect both of the oscillators. We'll hear that when I do a sound demo later. Moving down, we have the outputs. So output 1 is this oscillator, output 2 is this oscillator, and then there's another switch here in the up position. These outputs are completely independent, so I could send them off in different directions, put one through a filter, one through something else, or whatever. Or what I can do, flick the switch into the down position, and it does pretty much the same as what the CV switch does. It simply joins the two outputs together, again not buffered or anything. They just basically, the signal goes to the signal from both of those goes to both of those, so whichever one you plug into, you will get both the oscillators coming out, which can be useful. And the thing about this one, I haven't put a modulation input on this. Because of how I want to use the dual oscillator, having the crazy modulation for sound effects really wasn't appropriate for what use I put this to, so I just haven't bothered with that. But if you wanted to, yeah, you could put that on there, and probably put another switch on if you really wanted to share that as well. Could end up with some crazy effects there, but there you go. So yeah, that's very, very simple oscillator. The output from it is just a square wave output with a good frequency range, which you are about to hear. So let's have a listen to what they sound like in operation. What I have here is I've simply got the output from the VCO going into the mixer, and then I've got an output from another VCO on from one of the dual VCOs going into the mixer. So there's no processing. So what you're going to hear is what the oscillator sounds like. I'll talk about what the little tablet is doing here in a moment, but first of all, let's just wind this up. So quite a big range of sounds on there. If you want to hear what the modulation input sounds like, if I take the output from one of the other 4046 VCOs, put it into the modulation input, what you should hear now when I crank it up, and if I change the frequency of the oscillator that's modulating it, so all sorts of kind of weird sound effects that you can get out of it, which can be interesting, useful at times. Now we're talking about being able to tune these things. What I've got running on the tablet here, it's an application that's actually designed for monitoring vocal pitch. I don't know whether you can see this, but it's got kind of a scrolling graph, and as I'm talking, you can probably, because I've got a speaker system on here, so you can actually see what's happening. As I'm talking, you can see it flickering around, but if I start to bring the oscillator up, that's now telling me that that is somewhere around about the note of G. Now the way that I use these when they're not kind of a 1 volt per octave is I can set a reference tone. So if that's kind of, that sets the key that I'm going to be working in. That's F. And then what I can do then is the other oscillators, I'm going to use the other oscillators, I can tune them against that one that I've just set. Now I can either tune it by ear, or I can use something like this application, or if you've got a chromatic guitar tuner, you can use that. And then I can bring in, now this is where I can use the switch. If I flick the switch down on the outputs, I can bring in the second oscillator. My tablet is telling me that that's holding a steady G in octave 3. So if you wanted to play against that, there you go, you've set the key, play the key of G, and you should be able to play against that. So what does it sound like in terms of sequencing? Well, because it's not following the 1 volt per octave, if I plug the key step in and start playing the keys, it will start to try and then it'll not, and then it'll start doing it, and it's all over the place, and it's a bit of a nightmare. You can kind of find out which keys to press to get the output that you want, but it's a bit of a mess really. Now the beat step is a little easier to use if you're going to use. So the thing with the beat step, you can set it to, well, you can set it to various scales, but if you just set it to chromatic, so that basically you're stepping through on each of the step controllers, and you can tune each step by ear, and particularly if you're tuning it against a reference. I'm kind of look. So on the key step you've got a keyboard, which is difficult to work with. On the beat step you've got the pads, but then you've got these controllers for each of the pads. As I say, you set it chromatic, then you can actually dial in by ear, so you don't try and follow a scale. What you're actually doing, you're playing by ear. You're kind of listening to what you're creating and making it match. What's even better is if you've got a sequencer that isn't trying to give you a 1 volt per octave output, but in itself is linear. And the most common version of that is, if we go back up again, the Baby 8. So move this out of the way. If I now wire up Baby 8, and what I'm going to do, I'm using the gate, the CV out from the Baby 8. I'm actually, rather than switching the CV so that we'll do it. Switch it so it shares it, and then what we'll do, we shall put the output into a Victrola, and then we shall gate it. I'm using these utility modules just to kind of balance out all the voltages so that they they trigger good on the signals. So I need to turn on power to the Baby 8. So we have a sequence running on there. So what's happening here is, because I'm just going the CV into this first one, all you hear, turn that one down, all you're hearing is that sequence running on that oscillator going through that Victron. So what you're hearing now is the second oscillator that's been turning, and all that's happening is it's not running the sequence, it's just pulsing at a fixed tone because it's sharing the output through the Victron VCA. I can manually dial in the third one, and I've got kind of a drone and a sequence and a chord running. But what I can do, I can flick the shared CV switch down now. So both the oscillators in the dual VCO are now sharing the CV signal from the Baby 8, and they're both going through a single output and sharing the VCA. But what I can do is, because I can split the sequence signal there, and you can hear pretty much the same whether I split it on a balanced patch bay or flip the switch and run it as a dual VCO. Really wanted to. So I've now got all three VCOs running on the from the Baby 8 sequencer. And all I did with the Baby 8, I can slow it down. I tune each step while it's running slow to one of the oscillators, where's that one? So for instance, I tune that oscillator for each step on the sequencer, then I can bring in the other oscillators and I tune them against the first one, and then bring in the third oscillator and tune that one. So that's why I don't necessarily think that 1 volt per octave is absolutely essential. Yes, it's useful, yes, it makes life easier, but if you're going to work with a modular system like this, and you want to kind of get in there and be hands-on creative with it, then this is one way of doing it without having to worry about whether I can plug the keyboard in and play chromatically. I'm doing it anyway. I'm playing chromatically. You can hear it's a chromatic. It follows a chromatic scale, but it's all done by ear and by hand, and I'm actually playing the modular synth. And for me, that's a much more pleasing way of interacting with the machine to make electronic music. And yeah, these oscillators, great little oscillators, really simple, really cheap. So yeah, go on, have a go, build your own.